Hey, today, multiplying and dividing rational expressions on page 200 of your student journal. I want you to work with your partner to figure out how you can determine which values need to be excluded when finding product or quotients of rational expressions. Okay? So, go ahead and work together. Give yourself a couple minutes there. Come up with a good strategy. Okay, everyone eyes and ears focused up here, please. So, someone raise their hand and tell me how they went about this. Emma, what do you got? Okay, let me pause it right there. So, you looked at these that say multiplication. Said they can't be 0 down here or it's undefined because if you divide by 0, you get undefined. And so what made 0 here? Okay, so which one did that match up with? Letter F. Okay, so if you put -1 or 1, you get undefined. Therefore, those have to be excluded from x. So x could not equal 1 or -1. Okay. Hold on, I'm going to give someone else a shot there. Oops, that's really blurry. A little better there. Okay, so with that, using that process, letter B would be, volunteer? Yes, Haley? It could not be 1. So which one? Letter H, okay? X cannot equal 1, so it matches up with that one down there, okay. All right, and let's see, everyone tell your neighbor what your test number is. Like when you walk in, take a test, what number do you go to? Okay. So whoever is number 3 gets the shot at letter C. Who's number 3? Holy moly. Faith is not here. Okay. Whoever's number 1 gets a shot at it. Number 1, we don't have a 1 anymore. Whoever is, that's number 1 again. Whoever's number 21. You've got to be kidding me. Yeah, you're 21. Okay, what could X not be, Ethan? -1 or 2. Okay, so what letter is that? B? Oh, D. Okay. D is in darn. Okay. Okay, letter D. Letter D, that goes to number 22. Gotta be quicker. I'm counting to 5 and then I'm moving on. What do you got? Is it you? Okay, number 27. Number 12. All right. 1 and -2. Good. Okay, whatever makes those 0. So x cannot equal 1 or -2, which is letter B. Letter B is in. By golly, that's right. Okay. All right. E. How do we do E? Emma. Oh, I better give someone else a shot. Jenna. Okay, so you have to multiply by the reciprocal, so we're going to change that to multiplication, and then we're going to flip the back. Everyone agree? Yeah, you multiply by the reciprocal, and then use the same process as before, so I look at this, and that becomes x cannot be -2 or -1, which is letter G. Letter G? Okay, now I see a problem there, but I'm not going to point it out yet because it'll become evident here pretty quick. Okay, So that means in letter F, everyone tell your neighbor what the answer is. Okay, we flip it. So you get x cannot equal 2, and it cannot equal -1, which is letter? Hold on. You said 0. Why 0? Haley? Hold on, pause. Everyone pay attention. We're saying x cannot equal 0. How come? Good. So you've got to look at that, and that. Now notice why. Tell your neighbor why it didn't show up in this problem. Oh, we did flip that one, didn't we?
It's already there.
Yeah. Those are the same thing. So it carried itself through. So this is letter A. All right, well done. Okay. Tell your neighbor the answer for G and H. Haley, question. Oh no, I was going to give number 4 a shot. Who's 4? Oh, that's you. Go ahead. Okay, -2, 1, or 0. Well done. And that's letter C? All right. Okay, and the last one goes to 14. Who is that? Oh, that's me. All right, which is what letter? E. Way to lift up your teammate. All right, very good. Any questions? E for Evan. What do you think, Evan? Is it easy? Okay, here we go. I want you to take a look at page 201. No, you guys have 2 back there. I'm sorry. Okay. Kai, take a breath. Okay. Numbers 3 and 4 on page 201. Off you go. You guys, all of that aside, number 3, how can you determine the excluded values in a product or quotient of 2 rational expressions? Josh, what do you got? Okay, that's good. Start. How can you expand on that, Scarlett? Oh, it was just a second ago. I was giving you a shot. That exact thing? Wow. Okay, Jenna, how can you expand on that? Yes, the key piece is whatever will make the denominator 0. Okay, at any point, if the denominator equals 0, then it's going to be undefined. So the excluded values that make the expression in the denominator of each product or dividend 0. Those are the excluded values. So the question becomes then, is it ever possible for the product or quotient of 2 rational expressions to have no excluded values? In other words, one thing to point out, when you have excluded values, what do those look like on a graph? They could be wholes or asymptotes. Okay? So if you think back to your graphs that we've been graphing, we've had asymptotes, right? So let's just say I have these, I have a branch, okay? So those are this would be my excluded value. Maybe that's where x equals 2 or something. Okay? Is there ever a situation where you could have a rational expression, still has to be rational, can't be linear, something like that, What's it mean to have a rational expression? What's that? Good, an x in the denominator. So where you can have an x down here, doesn't matter where else x is, but x has to be down here. Is there any way to make a rational expression where there are values that are not excluded, or where you have no excluded values? Ethan? No? That's not correct. There is a way. I want you guys to figure out a way. Okay, what do you think? Ethan, what do you think? An exponent like an x squared?
No, if it's like the x is the squared or whatever. If it's like 2 to the x and then the x is up there.
All right.
2 to the power of x. Something like that.
No. That is not it. Kai.
When the numerator is the same as the denominator.
Then so if that's x over x, then that's 1, and that's a constant function. So x over x squared, and let me even make it easy. Let's like put a 2 up here. 2 over x squared, that is still has undefined at 0. Jenna? When will you never not be able to come up with a real number that equals 0? That will make the denominator equal 0. I tried to give you a hint in the question. When are you not able to come up with a real value that will make the denominator 0? Okay? You guys get about 30 seconds to talk about it. Person number 30. That's right, we don't. Person number 21. No, that is not correct. All right. That would be an example. Come on. There's a Saturday Night Live skit on this. I was going to say that. I did say that. Okay, now look. Y equals, now actually, let's just focus on the denominator. The denominator right there is x squared plus 6, and you don't want it to equal 0. If I subtract 6 over, I get negative 6, and then I take the root, I get x is equal to plus minus the square root of negative 6, which is, that is an I. No, that's not what he said. He said when they're, you guys are going to lose like 5 points. Look, do you see an I right here? No. Has nothing to do with I being in the denominator. I think that you were a little off. Okay? Now, here's what I'd like you guys to do, though. I want you, if this does not give you an excluded value, meaning there is not an asymptote or a hole or anything like that, I want you to graph that on your calculator real quick. Okay, can I have your attention, please? Hey. Okay, we need to move on, but I just wanted to give you some vocab terms. This is called a discontinuous graph. This is a discontinuous graph. Why it's discontinuous is because as you're graphing it, you're going to cruise along, and all of a sudden you have to lift up your pencil to go and graph the rest of it. This is your discontinuity is at x equals 2 in this graph. Okay, we call that a discontinuity. Now, in our other book, we focused a lot of time on that. I'll reference it a bit more tomorrow when we talk about your graphing portfolio page. This is a discontinuous graph. This graph right here that I just asked you to graph, which when you graph looks like that, which isn't much of anything until you zoom in. So if I go to zoom and I go zoom box, it was right around the middle here. Okay, so I'm going to just kind of draw this box around. Oops, that was a bad looking box. Let's try that again. Zoom what? Oh yeah, zoom fit. Let's try that one. That might be faster. All right. Okay, and so when you graph that, that's what it looks like. Notice if I were to draw the graph using my pencil, I wouldn't have to lift up my pencil. It is a continuous graph. Note those terms. This one's continuous. This one's discontinuous. If there are exclusions in your equation, or restrictions, we sometimes call them, those are called discontinuities. Those are things that x cannot equal. Okay, you're going to get a graph where you would have to lift your pencil. Otherwise, this would give you a continuous graph. Huh? English? What are you talking about? Are you like making fun of me in some way, Derek? That I don't know.
No.
Oh.
I'm just saying you're good at teaching words.
Oh, thank you.
Teaching math teacher.
All right. Hey, any questions?
Just not words.
Got to move on. All right. I want you guys to turn the page, please. Next page of your student journal has some examples. In fact, the next 2 pages have some examples. Okay, really what I want you to focus on, you can come back to those pages and kind of summarize what we did today. But really what I want to focus on is page 204. And I want to spend a lot of time on this, just going through some problems with you. So the first 2 ones we're going to work through are problem 1 and 2. Okay, we're just going to kind of go right down the page. Okay, I want you to work with your neighbors. Try to complete number 1. Simplify it if possible. Hey, volunteer to tell me what I just did. Emma. Yeah, I factored like the top. In fact, I actually factored the top. Okay? So this whole top part got factored. Good job. Very true. Okay? So do you have to do that? Did anyone solve it without factoring the top? How many of you factored the top? Okay. So I'm not quite done. So what do I do next? Okay. Factor the bottom. Okay, I'm done. So now what? There's no addition or subtraction. There's nothing to factor there. But if you could, you would. So there's nothing to do. But just so you know, Kai, there eventually will be stuff to do. Okay? Kai was just predicting the future, I think. All right. Scarlett? No? Okay. Go take a guess. You could simplify the 2x squared and the 6x squared. In fact, that's what I would do next. Okay, so Scarlett says simplify that, and Andrew, what does that become?
1/3.
For sure, 1/3. And x squared's cancel, right?
Yep.
So it just becomes 1/3. So you get 1x minus 4 over 3. Okay? We have now simplified that. Now, how does that even relate to what we just did? Like, why did we spend all that time at the beginning of the lesson doing all that exclusion stuff if we didn't even use it here? I don't know either. That's ridiculous. What was that, Haley? Nope, not quite. No, well, I'll tell you that this is part of our answer. We're not done with the answer yet. What are our restrictions? First person to raise their hand, tell me the restrictions. Get the point. Yeah, Kai. X cannot, it can't equal negative 3. Maggie? Why? Good. Yeah, if you put 0 in here, you get a 0 in the denominator. So 6x squared cannot equal 0, therefore x cannot be 0. Well done, Miggy. All right. Okay, just so you know, the point totals 1, 3, 5, 4. Okay, it's anyone's game. Number 2, off you go. Okay, check your work. Factor out an xy squared. Cancel the y squareds. Cancel an x. So you're left with 5y minus 2x over x. Can you just cancel the x's? No, that's a minus up there. You can't do that. Okay? You have to, that's like all being in one spot there. It'd be like you and a friend going to a movie and then you taking off without your friend. Like, see ya. Like, ditching them. That's no fun. Okay, you can't just like leave them. Yes? Hey, good question. At the very beginning, I can't cancel these out because there are implied parentheses up here. You're dividing both of these things by that. So some of you, like some people had in the first class, you could break it apart like this to begin with. I think this takes a little longer, but you could do that, and then you could reduce each fraction. Do I need to take your calculator away? Seriously, you're in math, and I've got to take away your calculator. It's like taking toys away in class. That's ridiculous. Okay? So I cancel that. I cancel all of those and one of those. Here I cancel all of those and those. So you would have 5 over x, or 5y over x, minus 2, which is the same thing as this. If you think of this one, like I would leave, this would be my answer. However, you could take that and say, well, that's 5y over x. Thank you. That's 5y over x minus 2x over x. And then those cancel. So you once again would end up with that. It's another way of doing it. Okay, I'd prefer this way. I'd prefer you leave it in this form. Okay? What are my restrictions? Volunteer on one of them. Kelsey? Yep. X cannot equal 0. Okay? There? And y cannot equal 0. Very good. All right, x and y cannot equal 0. Now, you'll notice that I picked 2 people from the same table, mostly just to annoy the people that are whining about the points. However, I know that's no one in this class, so it's probably the people that would hear that on the video lesson. They don't get called on at all. Like if you're at home watching it, Chase, if Chase is listening right now, he doesn't get called on. Sorry, Chase. We apologize to him. All right, Chase. Isn't that nice? Now he feels like he's at home. Hold on, he is at home. Now he feels like he's at class. Okay, number 3 and 4. Off you go. Make sure you factor first. And then reduce. Okay, there's our solution. So making sure that if it's not already factored, you factor it. Right? You can't just cancel x squareds because of the pluses and minuses up here. Okay, this is implied parenthesis, implied parenthesis. So you got to factor, then reduce by canceling quantities. Because these are multiplication, you can do that. You can you can cancel the pieces you're multiplying by. You're left with this, and since 1 forms 0 on the bottom, here or here, x cannot equal 1. So in this top one, you would have, take out x squared, and you'd be left with x plus 3. And in the bottom, you'd have to be able to factor looking at our restrictions right away, x cannot equal 8 or negative 3. And when we cancel, you left with x squared. X squared over x minus 8. And your restrictions. This stuff awesome. Woohoo! Okay. Hey, 2 more quick problems before we go today. Find the product or quotient. First, number 5. If you are multiplying, please know, do you have to factor either of those? Or anything?
No.
No. There aren't any addition or subtraction symbols. Therefore, we just can start reducing or cross-canceling or cross-reducing. So the first thing, if I'm looking at this, is there anything that cancels top and bottom? X and AY. 1Y. Okay? Anything that reduces here? Anything that will cross-reduce? Yes, the Y's. Anything that will cross-reduce? No. So numerator, 3 times 1 and 2x. What are my restrictions? Scarlett? Okay. Darren? Good. X and y cannot equal 0. Very good. Because of that x and that y. Both on the bottom. Okay. Number 6. What do you have to do with that one first? You got to flip it, right? The way I flip it is I just change that to multiplication since it was division. And I move that y up here and move that 4x down here. I didn't hear you. You can't reduce until after you flip it. Until after you flip the back. Okay. So, go ahead. You cannot, because this is together up here. You could reduce these y's. You could. But because there's that plus, you can't reduce. Correct. So, we're left with x plus y on top over 7x on bottom. Remember, you can't reduce because those are coupled together. They go together. X cannot equal 0. What else? Oh, 28x. Whoa, my goodness. Oh, I'm sorry. 4 times 7, 28x. You guys get a point for that. 28x. Oh, x squared. Man, I really messed up. Thank you. I know. I'm sorry. I'm rushing here. Okay, I'll blame being in a rush. All right.